X-ray, it's like when high speed electron is striking on any metal target. You can look at this diagram. This one is one metal target, and basically this generates some electrons. So if high speed electron is striking on the metal target, so in that case, are being generated. So whatever photon are being generated, we say it's X-ray. So X-ray production happen due to striking of a high speed electron on a metallic surface. How this is happening? This one is one filament. It generates electron. We have a setup of voltage and everything. Here one metal target is there. This one is water coolant to cool this point so that whatever heat generated will be there, it can balance that cooling. Now this electron collide on this surface and photon will be generated. This photon itself is called X-ray. And if you see the range of this X-ray, in experiment we had seen the range of this X-ray is between zero point 0.1 angstrom to 100 angstrom. And whatever metal we select here, so there should be some property for this metal high melting point, because if melting point will be less, in that case when electron will strike, this metal will melt, they may melt. So it might melt this metal. So that's why we always select high melting point. So first property of this one, melting point of this one should be very high. Second property of this one, this filament, this metal is like high thermal conductivity. Conductivity should be very high so that this coolant can work for that one. Third is high atomic numbers. More number of electrons should be there, more number of protons should be there basically. So more number of new electron will be also there. So it should have a high number of a atomic number so that more number of electron will be there to balance that proton. So there are three property for this one: high melting point, second one high thermal conductivity, and third one is high atomic number. Now if we move to working of this tube, what is happening? Two type of X-ray. So X-ray basically we can divide into two part. One is continuous X-ray and second one is what? Characteristic X-ray. And what are they? What are continuous and characteristic X-ray? So if you see the atomic structure of this metal, whatever metal we use, tungsten basically we use, whatever metal we are using. So if you see the atomic structure, so there will be nucleus, there will be so many electron as well. Now if one electron is coming from this one and passing through this metal, so what will happen? It will lose some energy. So let's say energy at this point is half mv square. After passing through this one, energy will become half mv dash square. So whatever loss in energy will be there, that creates X-ray, that creates photon. And energy of that photon we can write in this way: half mv square minus half mv dash square is equal to h into nu. And if complete number of electron, a complete energy of a electron is being absorbed, let's say this electron complete energy is being absorbed inside this metal, it means final kinetic energy, this kinetic energy will be zero. So if this kinetic energy will be zero, in that case what I can write? Half mv square is equal to h nu. And when this kinetic energy will become zero, this one, in that case what will happen? This nu will be maximum, or in other word we can say hc by lambda minimum is equal to half mv square. We can write ke, because if this nu will be maximum, means nu is inversely proportional to lambda, so lambda will be minimum. So if we have to calculate this lambda minimum, so what I'll write? hc divided by ke, and ke is what? Kinetic energy, and this kinetic energy we can write hc as it is, and kinetic energy we can write ev. So that's how we calculate minimum wavelength of a X-ray. Now this one is which X-ray? This one is called continuous X-ray. This X-ray is called continuous X-ray. Here nothing, no ejection of electron, like electron is not jumping anywhere, just this electron is losing some energy. Initial electron losing some energy, and if it is losing 100% of energy, that case only wavelength will be minimum. So if wavelength minimum I need to calculate, then in this case Hc value, H is constant, C is constant, E is electron, and we can write this value 1 we can write this value 12400 angstrom divided by V. So that's how we can calculate value of minimum wavelength. Now one important point, so this minimum wavelength, this lambda minimum, it only depend on voltage. You can see it only depend on voltage. It does not depend on the nature of material, what type of material we are using, that doesn't matter. It only depend on nature of a it does not depend on the nature of the material. It only depend on how much voltage we are applying for that. So we apply voltage between the target and filament. So it only depend on the voltage applied between target and filament. Now, if we increase this voltage, so you can see here lambda minimum going to decrease, but new frequency going to increase, energy going to increase, penetrating power going to increase, current will increase, heat will increase, and electron emission will increase, and intensity will increase. So this is the important point to remember. This all quantity lambda minimum has to decrease, and rest of the quantity will increase in this X-ray. All right. Now this is the continuous X-ray. Now, what happened to this? If this electron is colliding with another electron, let's say this electron, so it will apply some force and it will give some energy. So what will happen? This electron might jump from this cell to somewhere else. Let's say this electron jumping from this cell to here. Now, when this electron again return back, so it will emit some energy. So that type of X-ray is called characteristic X-ray. This one, characteristic X-ray. So in continuous X-ray, what is happening? Electron in the cell, they are not jumping, they are the same place. But in case of characteristic X-ray, what is happening? This electron will jump after collision, again it will return back. So when this electron will jump, then vacancy will be created and again return back, so that vacancy will be filled. So due to this one, X-ray, whatever energy will release, so that is the type of a characteristic X-ray. Now, what is happening in this case? Let's say electron jump from first cell to second cell. This to first to second. Now, when it return back from this cell to this one, so we say this one is K alpha. If we return from this to this, means M cell to K cell, we say this one is K beta, and similarly we say K gamma and so on. Now if it is returning from M cell to L cell like this one, so this is called L alpha and this one will be L beta, and similarly this one we can say M alpha and this one will be M beta, like other cell is there, is coming from here. Now if I want to find out wavelength of any transition, let's say I want to find out wavelength of this transition, between these two transition I want to find out what should be wavelength. So for that we have a formula, 1 by lambda is equal to R Z minus B ka square 1 by N1 square minus 1 by N2 ka square. Now Here we are using one constant that is called screening constant for K alpha. This screening constant B is equal to 1. So using this formula, we can find out wavelength of characteristic X-ray. So let's take one example for that one. I have K alpha line which Z is equal to 57. One element is there. Now another K alpha line is there. Let's say Z is equal to not 57, it's a 29. So wavelength for K alpha line with Z is equal to 57, let's say it's X. So what should be wavelength of this one if atomic number is 29? So for that I can use this formula 1 by lambda is equal to Rz minus B square 1 by N1 square minus 1 by N2 square. Now rest of thing you can say it's a constant. So I can write lambda 1 divided by lambda 2 is equal to Z2 minus B divided by Z1 minus B ka square. So lambda 1 is what X, lambda 2 I have to calculate, and Z2 is what 29 minus 1, and this one is what 57 minus 1 ka square. So if we solve it, so X is equal to, you will get lambda 2 divided by 4. It means lambda 2 will be equal to 4x. So this is one numerical based on characteristic X-ray. So let's move forward. Let's see the diagram. Let's see the graph of characteristic X-ray. It will be something like this. This point, like y-axis, we are representing this y-axis. We are representing intensity we are representing on y-axis, and x-axis there is wavelength. This one is continuous X-ray, this one is continuous X-ray, and this one is characteristic X-ray, this one also characteristic X-ray. So basically in this region electrons are not jumping and not returning back, so it's a continuous X-ray. This region not returning back, continuous, this one continuous. This is characteristic X-ray because electron jump and return back at their same position. So that is why. Now let's solve one numerical based on that. And in this numerical, it's a given if wavelength of a K alpha line is 0.036 nanometer, then calculate difference in energy of K cell and L cell. So basically it's a jumping from L cell to K cell. That's what K alpha is. K alpha means what? Electron is jumping from L cell to K cell. It means wavelength, how we can calculate energy, how we can calculate, not wavelength. Energy is equal to, that will be Hc by lambda. And if I put this all value Hc and lambda, so what we'll get finally, this one 1240, and this lambda will be 0.036, and if I calculate this one I will get 3.4 into 10 raised to 4 electron volt. So that's how we can calculate energy. This one in the electron volt, if you want to convert into joule, so in that case what we can do, just multiply by 1.6 into 10 raised to minus 19, so we can convert into joule as well. Now relation between their wavelength, for example you can write here ek beta. If you look at this diagram, ek beta is equal to ek alpha plus el alpha. It means I can write Hc divided by lambda k beta is equal to Hc divided by lambda k alpha plus Hc divided by lambda L alpha. It means 1 by lambda k beta is equal to 1 by lambda k alpha plus 1 by lambda L alpha. So this is the relation we can derive in this transition. Ask is Moseley law. Moseley said कि Moseley said square root of a frequency directly proportional to atomic number. So he gave a square root of frequency directly proportional to z minus b. And if you remove this constant, so we get here a z minus b, where a and b are constant. So I can also write this formula nu n divided by nu 2 is equal to z1 minus b divided by z2 minus b ka square. And we can also write here lambda 1 divided by lambda 2 is equal to z2 minus b divided by z1 minus b ka square. Because we know frequency and wavelength, they are inversely proportional. So I can write this equation. So this is all about X-ray.